Hi everybody, my name is Rob from RobOps, and today we're going to be going through the full environment setup for our Kubernetes cluster experiments. In this video, we're going to be setting up our API on a Kubernetes cluster that will be highly available, scalable, and resilient. This is what we're going to be building in this video. It's an API that's available at api.anytimeagile.com. It has various endpoints at /users and /compute. The API itself is hosted on a highly available EKS cluster. In this video, we're going to show how you can go from the available repositories to a fully working API of your own. So before we actually start the video, we're going to go over the architecture and the tech stack to get more familiar with what we're actually deploying. Then we're going to go into a repository overview. For this video, we're going to be using two main repositories, our Infra repository and our API repository, both of which are available on my GitHub page. We're largely going to be working with the Infra repository for this video as it has all of the infrastructure as code. Next, we're going to go over the prerequisites. And so in this section, we're going to make sure that our accounts are set up properly across AWS and MongoDB, our CLIs, and there are a few resources that we're going to have to set up outside of this infrastructure as code to make sure things run smoothly. Finally, we're going to go into the infra deployments. This is what's going to actually deploy the architecture. And then once that's deployed, we're going to be able to deploy our infra apps to our EKS cluster. This is things that are going to be supporting our API, like ArgoCD, Prometheus Grafana, external secrets. And then finally, we'll deploy the API itself to the cluster, and then we'll see the end-to-end environment setup. So this is what our architecture looks like at a high level. As you can see, we have a two-tiered VPC with private subnets and public subnets. We have our EKS clusters deployed into the private subnets. We have a CloudFront distribution that's going to be managing a lot of the ingress traffic and forwarding that traffic to our network load balancer. That network load balancer is going to take that traffic and distribute it into our clusters. We're using Route 53 and Cert Manager to manage our DNS, and our data layer is going to be MongoDB. And so traffic is going to egress out of the private subnets through our NAT gateways and into our MongoDB to establish that connection. So when it comes to our tech stack, all of our infrastructure mostly is going to be deployed to AWS. We are going to have our data layer that's going to be existing in MongoDB. And so those are going to be the two major infrastructure providers for this experiment. When it comes to deployments, we're going to be using GitOps, and so ArgoCD is going to be a staple that we're going to deploy to our EKS cluster. And this is what's going to allow us to deploy changes to our API as well as our infrastructure and have it reflected in real time in the cluster. From a monitoring perspective, we're going to be using Grafana and Prometheus. And so this is what's going to actually allow us to observe what the impacts of these state changes are to our clusters as part of these experiments. Finally, we're going to be running a simple Go API, and so this is what's going to act as the actual service itself. It's going to be serving multiple different endpoints that allow us to interact with the API, interact with the data layer. When it comes to the repositories, we're going to be working with two major repositories, our infrastructure repository and our API repository. Both have very detailed READMEs that are going to be going through the exact steps that we're going to be walking through in this video. So I'd encourage you to open those repositories up. Links are in the description and follow along as part of this video. Okay, so prerequisites. What do we need before we can actually start deploying? Well, we're going to need a few tiers of things. Obviously, probably most obviously, we're going to need an AWS account and a MongoDB Atlas account. The AWS account you will need to set up with a credit card because we're going to be deploying resources into it, and you will have to pay for the resources that you do deploy and use. MongoDB, on the other hand, will allow us to deploy a free cluster, and so there's no credit card information or anything you have to hand over for that. We're going to be setting up our CLIs, and so we're going to need to be able to interact with AWS, the AWS CLI for our EKS cluster configuration, and we're going to have to obviously interact with Terraform to apply all of the infrastructure that's part of our deployments. From a resourcing perspective, the only thing we really need is the hosted zone to be defined in Route 53. We could do this in code, but it just makes things a lot easier if it's outside of our infrastructure as code. If you do plan on using sensitive variables in your application, you will need to set up Secret Manager. And if you are using a remote state with your Terraform, you will need to set up a remote state bucket and DynamoDB table to track the lock files. If you plan on using the GitHub Actions, I would recommend setting up remote state. Otherwise, you will get into trouble with the destroying of the resources at the end of the tutorial. On the MongoDB side, you will need to set up a free M10, I believe, cluster, and that's what's going to act as our database for the experiments. There is a cost associated with doing these experiments. The end-to-end infrastructure for this experiment will end up running approximately $4 per day. So the resources that we're using in combination with the infrastructure associated with them, it does cost money. And so I will highly encourage, and we will walk through this in the video, to destroy all of the resources when we're finished. But once all of those things are set up, we're going to be able to start setting up the environment. So here we are in the console, just going over kind of the hosted zone that I have set up for my domain, Anytime Agile. So I purchased this domain, and when you purchase the domain, you get these name server details that you can set up your records within Route 53 with. Secondly, from the Terraform remote state management perspective, we have a bucket created and a DynamoDB table. The bucket is for the Terraform state, so that it'll allow us to manage the remote state. And in a similar way, the DynamoDB table manages the lock file for our state. Finally, we have a simple secret set up in AWS Secret Manager. This is what's going to contain the sensitive connection details to our MongoDB. Now, all of these things could be set up in infrastructure as code, but for the sake of simplicity, I chose not to include them in the general repo, as these are things that are typically more long-lived. And so they're going to kind of continue to exist outside of our Terraform state. So with that out of the way, we're going to switch over to our code view. And here we are going to pull the repo. And once we've pulled the repository, you'll notice we have a bunch of files in here related to the Terraform. The ones that we need to set up before we can run any commands are our example files. So typically what we would do here is we would go to these example files and we would just simply remove the example from the end of it. And so you can quickly go over here and you can just rename it as .tfvars, and that's how we would set up this information. Fortunately for me, I've obviously already set these up, and so I don't need to necessarily create new files. So if we look quickly first at our backend config, this is what's going to configure our remote buckets. We can see my bucket name, Terraform state bucket K8s API, which is what we went over earlier. The key is anything you decide it to be. This is just going to be the subdirectory or the prefix that your state file gets stored into. Your region is the region that your resources will be deployed to. You should ensure there is some consistency here. And finally, the DynamoDB table name is simply the table name of your DynamoDB table. Moving over to the TF-vars, this one is a bit more unique in the sense that it's unique to our project. So we have our AWS region, US East 1, our environment, just dev for this project. Our project name is K8s API, and our backend bucket key, and DynamoDB table. Very similar information to our config backend are all here. They're all the same values. Our cluster name for our initial setup, I'm just going to call it my EKS cluster. Our node group name is going to be my EKS managed nodes. My repo name is going to be my repo. This is for the ECR repo that will be created. We'll have EC2 SSH keys, which is our key value pair. It's just called K8s key value pair. Now for the CIDR range, we're using the 10.0.0 space. Obviously, if you have other VPCs within your account and other network to be mindful of, you would choose your CIDR range mindfully to prevent overlaps. But for this case, I don't have any other meaningful networks running in my AWS environment, so I can use the 10.0 space. The /16 is quite large. You won't need that, but just for the purpose of this experiment, like I said, I'm using a /16. The availability zones that we want to deploy to are 1A, 1B, 1C. Depending on the needs that you have, you can configure these differently, but I do recommend 3 so that we have that high availability. From the alias perspective, we want our API to be available at a sub prefix or a subdomain. And so I typically do API.my fully qualified domain. And so API.anytimeagile. The zone name and zone comment are simply config values for our hosted zone. And then the domain name itself, which is where you will go to hit the API itself, is API.anytimeagile. So once we have all of those things set up, we're ready to run our applies. And you'll notice we're going to be, for this experiment, we're going to be mimicking in the workflows directory of our GitHub folder. We're simply just going to be running through this this GitHub action. And so you can see it simply sets up Terraform. So it runs a Terraform init, and it's going to initialize our remote state. Then it applies the core infra modules. It applies our Ingress Nginx Helm chart module. And then it creates our CloudFront and our A records for Route 53. So we're going to do this in 3 different applies, and each apply will slowly start to form or build the basis for our architecture. Okay, so we'll pull up the terminal here, and as we can see, we have our Terraform CLI working. I'm going to run a Terraform init, and this is going to initialize my remote state. I'm simply going to run Terraform init. I don't need to supply all of the secrets as indicated in the workflow because my TF backend file is in the same directory that I'm running this from. And so if I quickly go over to our Kate's API infra, I can see that I have my Terraform, my backend config.tf backend, which has my values. And so I can just simply run a Terraform init, and this should initialize my backend. All right. Okay, so now we're ready to do our first apply. And so I'm going to specifically target the modules that I want to apply, and I want to also provide a vars file so that my apply will take into consideration the values that we've configured ahead of this experiment. And so if you look at this, it's going to apply and use our var file that we've provided, and it's going to target our IAM module, our VPC, our cluster, and our managed nodes, along with our security groups. So we're going to apply, and we're going to see what kind of plan is generated. So as we can see, we're going to add 26 resources, and if you scan through it, it'll be largely our network, along with a few key components of our EKS cluster. So this looks all good. I'm going to click yes, and we're going to watch this apply. Okay, so our first set of changes has now been applied, and we basically now have an EKS cluster and no way to get to it. And so the next set of applies are going to apply our ingress to the cluster. So our first Ingress Nginx, so the controller that's going to route requests into our cluster, and then the CloudFront, which is going to act as our main ingress. So to do the second apply, we're going to go over to our commands. Or back to our terminal rather, and the next command we're going to run is to apply our Helm release, Ingress Nginx. So here, we're going to use the same reference to our vars file, and we're going to apply this. It's going to refresh our cluster state, and it's going to add one thing, and the one thing is our ingress, which is what we expect. And so we're going to simply click yes, and now this is going to apply. So that one was much faster because it was just a single resource, and we have our ingress applied. Now for the final step, we're going to apply our CloudFront and a few A records that will allow us to link our domain to our CloudFront to get the end-to-end API up and running. So here we go, apply this. And we'll take a look at the plan for this one because it will show specifically 5 adds. It's going to add a few Route 53 records. It's going to validate our cert, and it's going to create our CloudFront. Yes, and this will also take a little bit of time to create. Amazing. So our infrastructure has been successfully applied. We've applied approximately 36 resources, and our environment is set up. So this is what represents the underlying infrastructure that we are going to now deploy our services and infrastructure apps to. If I pull up the terminal and I configure my kube context to the cluster I just deployed by simply typing AWS. As you can see, our CLI is set up. So if I go AWS EKS, update kubeconfig, name of my cluster, which is my EKS cluster, and region, which is US East 1, this will update my kube context. So now I can use my kubectl commands to access my cluster. So if I go get pods, all namespaces, I will see that I have a simple cluster running with an ingress nginx controller that's acting as an ingress. So now we're able to go and deploy our infrastructure apps. And so the infrastructure apps we're going to be deploying are ArgoCD to manage our deployments, Grafana and Prometheus to manage our monitoring and observability, and external secrets, which is going to handle the external secrets for our cluster. So if you go back to my GitHub page and you go to the repository called Kate's apps, this is simply a reference. I would encourage everybody to configure the services that they're going to be using themselves. But this is a very straightforward way to just apply boilerplate versions of ArgoCD, Grafana, Prometheus, and external secrets. And so I've provided a set of GitHub Actions in the Actions tab to deploy ArgoCD, deploy external secrets, and deploy monitoring. So I'll simply go over here and run these workflows. And this is going to deploy everything to our cluster. So these workflows will run. And if I go to all workflows, we can see they're all running. And when they're successful, we'll come back and go over the setup instructions to get them running. All right, so all of those processes have run. And if we go back to our console view and we simply run the exact same command we just ran to get all namespaces, we'll notice we actually have a lot more things running in the cluster. We'll see our ArgoCD application controller along with its supporting pods. We'll have our external secrets pods, and we're going to have our monitoring pods representing Prometheus and Grafana. So we're going to start with ArgoCD, and for that, we're going to need to do two things. First, we're going to have to pull the initial admin secret from our cluster so that we can log into the UI. Secondly, to access the UI, we're going to need to port forward ArgoCD that's running in our cluster to our local machine. First, we're going to run the following command to access the initial secret. So here we get the secret. We're going to copy this into our notepad for later. And then we're going to run the port forward command. And so it's simply going to be k port forward our ArgoCD service to port 8080. Click enter. And now we're port forwarding. So now if I switch back to my console view and I go to localhost 8080, it's going to give me this privacy error because our connection is not private. Let's simply proceed to localhost, and we're going to see our ArgoCD. So our username is going to be admin, and we're going to copy that password from our notepad into the password field, and we're going to sign in. So here is ArgoCD. We have no applications yet, and we have no repositories linked. And so in order to configure ArgoCD, we're going to have to link it to our GitOps repository, and we're going to have to configure a few applications. We'll do that after we configure the rest of our infrastructure apps. Next, we're going to need to set up Prometheus and Grafana. To do that, we're going to run a very similar command in our console, and we're going to switch back to our code view. And so here, we're simply going to run a very similar command, except instead of port 8080, we're going to run it on port 3000. That's okay. Port forward the service monitoring Grafana, and we'll see we're now monitoring. And so once again, when I switch back to the full screen view and I go to localhost 3000, we're going to be greeted with the Grafana login page. In a similar way, we have the admin user, and our password by default is going to be prom operator. And if I log in, we have Prometheus Grafana running in our cluster. I can look around and look at the pre-baked dashboards that are available, and you can see it's already monitoring our cluster. We can see our ArgoCD pods along with a few other ones. For the next step, we're going to head back to our code view. So we're going to take a look at this GitOps folder. This GitOps folder is a private repository that represents the state of our Kubernetes cluster. The way it's structured is I have an apps folder, and then the apps that I have deployed to my cluster represent their own folders. In those folders, I have a YAML that describes how the resource is configured in Kubernetes. Now, what we're going to do is make sure ArgoCD watches our GitOps repo. The reason for that is it's going to make sure that any changes to our GitOps repo get reflected in our cluster. And so in order to do that, we're going to switch back to our ArgoCD view and configure the application. So the first thing we want to do is go to Manage Your Repositories, and we want to add or connect our GitOps repository. We're going to do this through HTTPS. Name is optional. Project, I'm going to say default. We're going to need our repository URL. So if I go back to my GitHub page, I can actually show you the GitOps repo. It is private, and so you won't be able to access this directly, but I would strongly encourage you to set up your own GitOps repository. Now, if I go back and I paste it, I'm going to need to add my username and password. So my username for my GitHub account is Robert DiPolito, and I have my PAT, which I'm going to also add so that ArgoCD can connect to our cluster. And that's all you need. And I click connect, and we can see we've successfully connected. The next thing we want to do is go to applications and create some applications. Similar to our GitOps repository, we want to create the same application that we have in our repository apps. So the first one is going to be Kate's API. We're going to put it in the project default, and we're going to make an automatic sync policy. The repository URL is our GitOps repository, and the path, if you'll remember, is simply apps/Kate's API. The cluster URL is the default cluster service URL, and the namespace that we want it to be deployed to is API. Once we're done, we can click create. Now you'll also remember we have an app for Ingress Nginx, and so I'm going to create that as well. And so with all that set up, we're going to click create, and this should create our app. Now you'll notice our Kate's API is degraded, and that makes sense because we haven't deployed it yet. But our Ingress Nginx should sync with the cluster and become healthy shortly. As we can see, things are getting configured, and GitOps is syncing Ingress Nginx with our GitOps repository as expected. We're going to head over to our API repository, and we're going to go to Actions, and we're going to go to Deploy Helm chart. We're going to run this workflow, and we'll see it execute. Once the action completes, we can go back to our terminal and see if our API namespace has been populated. If we go Kate get pods dash in namespace API, we'll see we have a pod running, but it's an error. And so if we go on to ArgoCD, we can see our application is now synced, but we do have an unhealthy pod. And if we look at the details of that pod in the events, we can see it's in backoff, and the logs says it failed to connect to MongoDB. If I go to api.anytimeagile, I'll notice I'm getting a 503 service unavailable from Nginx. This tells me that we have to go check out the connection between our EKS cluster and MongoDB. To do that, we're going to hop over to MongoDB and we're going to sign in. The reason it's unable to connect to our MongoDB cluster is simply because of the network access. We don't have our IPs from our NAC gateways allow listed with our cluster. In order to fix that, we're going to go to our VPC tab within our console. We're going to go to our NAC gateways. And this is our NAC gateway, devnat. And it has a public IP address here that we're going to copy. And we're going to go to our NAC, our IP address. And this is what's going to enable network access to our MongoDB cluster. So I'm going to go add IP address. You have to add a CIDR range. So I'm adding a small one. And I'm just going to say, keep this for 6 hours. Confirm. Now we see the status pending. And once this IP address is allow listed, we'll be able to resume the connection that we expect with the cluster. So we see the pod flip, and if we look at the details of the pod now in the logs, we can see running in a production environment, server is running. So now if I go back to API at Anytime Agile and I click refresh, we get our API. And if I check the various endpoints, our users, you can see that it's successfully fetching information from our MongoDB cluster. And if I go to our compute endpoint, I can see that it's successfully loading our burn endpoint. If we go back to our Grafana dashboard and we switch our namespace to API, we can now see the exact moment when our API pods were deployed and unable to connect to the point where they came online and they started using CPU. We can also look at the applications. We have our Ingress Nginx, our controller, and our default backend. Then we have our Kates API with our external secrets being loaded in via external secrets. And we have our service, deployment, horizontal pod autoscaler, and our ingress. So that concludes the setup. We now have a fully working API that is resilient, highly available, and will scale on demand. So like I mentioned at the beginning of this video, we're going to want to destroy the resources we've created in this video to not incur any unnecessary charges. And so to do that, we're going to have to run two commands. First, we're going to have to initialize our Terraform backend if we are using our S3 backend. If you're not using the S3 backend, you can simply run a Terraform init and then a destroy because your state file will be local to your computer. But if you are using a remote state, you're going to have to connect to it. And to do that, the commands are here in the video. First, we're going to run a tf init and we're going to reference our init variables. And once we do that, then we're going to run a Terraform destroy and we're going to reference the M file that we had initially set up. So we're going to let this plan and it's going to destroy all of our resources and then we're going to click yes. In my experience, I've had to run the destroy a few times simply because the load balancer itself is a little bit sticky and doesn't get deleted automatically. And so just running this Terraform destroy, and if it times out, just running it again will fix that problem. So once you're all said and done and you get a Terraform destroy, you can run Terraform destroy again to check and it should say 0 resources to destroy. And with that, that concludes the video. I really hope you were able to take something away from this. If you did like the video, please leave a like or subscribe. And if you have any suggestions about future videos, or if you have any questions about the video itself, please do comment it below. Thanks again and have a great week.